Picture this. You are the chief security officer of a billion-dollar chemical manufacturing plant. You have just spent $200,000 on a state-of-the-art perimeter security radar. Your fences are secure. Your cameras are watching. But at 2 in the morning, a $500 quadcopter, painted matte black, flies silently over your fence. It hovers directly above your main power transformer. It records thermal video of your production lines, maps your security patrols, and flies away. Your expensive radar system saw absolutely nothing. No alarms. No alerts. A complete security failure. Welcome to Black Box UAV. Today, we are stripping away the marketing lies of the counter-drone industry. We are going to explain the Micro-Doppler Radar Gap and exactly why commercial drones are so good at evading industrial security systems. If you are protecting a factory, a data center, or a shipping port, pay very close attention. To understand why drones are invisible, you must understand how traditional security radar actually works. Most industrial radars use a principle called the Doppler effect. They bounce radio waves off objects to measure their speed. If a truck is driving toward the factory, the radio waves bounce back compressed. The radar software says, "I see a large object moving at 30 miles per hour," and triggers an alarm. But radar systems have a fatal problem. They suffer from something called ground clutter. Trees blowing in the wind, waving grass, or moving machinery all reflect radio waves. If the radar triggered an alarm every time a tree branch moved, the security team would go crazy. To fix this, radar engineers use software called an MTI, or moving target indicator. This software acts like a digital filter. It is specifically programmed to ignore anything that is stationary or moving very slowly. And this is exactly where the drone pilot wins. When a commercial quadcopter flies up to a factory and hovers in the air to take a photo, its forward speed drops to 0. The radar's digital filter looks at it and assumes it is just a piece of metal on a building, and deletes it from the screen. But wait, you might say, what about the drone moving slowly? This brings us to the second massive vulnerability, the radar cross-section, or RCS. This is a measurement of how big an object looks to a radar. A commercial drone is made mostly of plastic and carbon fiber. Radio waves pass right through plastic. Only the small copper wires, the battery, and the motors reflect the signal back. To a traditional X-band radar, a DJI Mavic drone has the exact same radar cross-section as a Seagull or a pigeon. If the security software alarms on every bird that flies over the factory, the system becomes useless. So, the engineers configure the radar to ignore small, slow-moving biological objects. By trying to ignore birds, they accidentally create a massive blind spot for drones. So, how do you fix this? How do you tell the difference between a bird and a spying drone? The answer is Micro-Doppler technology. Remember, a hovering drone has a body that is completely still, but it has 4 propellers spinning at over 7,000 revolutions per minute. A high-end Micro-Doppler radar does not just look at the main body of the object. It fires high-frequency radio pulses to detect the tiny, microscopic vibrations and movements on the object itself. A bird flying through the air flaps its wings at a low, biological frequency, creates a smooth, slow wave. But a drone's plastic propellers spinning at extreme speeds create a violent, high-frequency radar flash. This is called the blade flash effect. Advanced AI algorithms analyze this Micro-Doppler signature. If it sees the high-speed blade flash, it knows it is a mechanical threat, not a bird, and immediately triggers the alarm. But relying purely on radar is still a dangerous game. In industrial security, true protection requires sensor fusion. You need a Micro-Doppler radar to detect the physical object. You need radio frequency scanners to detect the drone's telemetry signal and locate the pilot hiding outside your fence. And you need automated thermal cameras to visually lock onto the target and confirm the threat. If you just buy a basic radar out of a catalog, you are leaving your multi-million-dollar facility completely exposed to a $500 toy. Do not rely on marketing brochures. If you are an industrial security director, an infrastructure manager, or a systems integrator, you must rely on real engineering data, not sales pitches. True airspace security requires understanding the physics of the threat. Equip your team with real knowledge. Secure your airspace. Subscribe to Black Box UAV for more hardcore drone defense engineering, and I will see you in the next analysis.